Hello friends, today we are going to do the assignment problem using the Hungarian method. Today's problem is the simplest problem which I have taken as an example. Let us look at the problem here. Consider a job which requires 4 activities like cutting, assembly, finishing and packaging. 4 workers are employed who can do all these activities. The time required by each of them in minutes to perform each of these activities are as follows. Now, here we have the matrix which gives you the activities C, A, F, and P, and there are 4 workers 1, 2, 3, and 4. These are the time taken to complete the activity in minutes. Okay. Now, the question is, how should these activities be assigned to workers so that the job is completed in minimum time? Now, let us try to solve this problem. First of all, let me tell you one thing. In all your assignment problems, the first thing you need to see is whether the problem is a balanced problem. A balanced problem is a one which has equal number of rows and columns. So if you look at this problem here, there are 4 rows and 4 columns. Okay, so it is a balanced problem. So let us write the value here. So we have, let us say n is equal to 4, which is your rows, or you can say columns. Okay, we will require this when we do the further steps. In the Hungarian method, the first step is to find the row reduction or row subtraction. Now, what is this row subtraction? What we are going to do is we will find the smallest element or the number in each row. Okay, so for example, the smallest number in the first row is 12. So the smallest number of the first row, I'll be taking this and I'll subtract the smallest number in each row from all the other elements in that particular row. Example, if 12 is the smallest number in the first row, I'll subtract 12 from 14, from itself, from 15, and then from 15. And similarly, I'll be doing it for the rest of the rows. So let us do that. So I'll quickly write this matrix here. I have less space, so I'll just write 1, 2, 3, 4, C, A, F and P here down. Pardon me for that. The numbers, let us say we have the first number as 14. So 14 minus 12, which is the smallest number, will give me 2. 12 minus 12 gives me 0. This gives me 3 and 3 again. The next row has minimum number as 18. So let us do the subtraction for all the other elements. So 12 minus 18 will give me 3. Then 0, 0 and 4. Next one, 12 is the smallest number. After doing the subtraction, we get 2, 5, 0 and 2 again. And the last one, we have 3 as the smallest number. So 6 minus 3 gives me 3, 2, 0 and 3. This is my reduced matrix from the first step. Now going to the next step, I'll be checking the smallest number in a column. So these are my columns. I'll take the smallest number. Okay, for example, the smallest number in the first column is 2. Okay, and I'll take the smallest number and subtract all the elements of that particular column now. Okay, so let us write this matrix, the second step. Here I'll put the second step, step number 2. Let me write the matrix. So 1, 2, 3, 4. We have C, A, F and P. Okay, so from this 2 is the smallest number. I'll minus 2 by itself. So 2 minus 2 gives me 0. That's 0. Then 3 minus 2 will give me 1. So I put 1 here. 2 minus 2 gives me 0. And again you see 3 minus 2 will give me 1. In the second column, as you see, the minimum number is 0. Okay, so even if we do the subtraction in this column, there won't be any changes. Similarly for column number 3, so I'll write down the column number 2 and 3 as it is. So we have 0, 0, 5 and 2, 3, 0, 0, 0. Now let us look at the fourth column. The smallest number is 2. Okay, so I'll perform the subtraction. I'll subtract 2 from 3, then from 4, from 2 itself and 3, and I'll get the answer as 1, 2, 0 and 1. Okay, now after the second step, we get the reduced matrix. Okay, what is the third step now? The third step is to draw horizontal or vertical lines to cover maximum zeros in a particular row or a column. Okay, you have to be careful. You need not draw multiple lines such that you are not covering maximum zeros. For example, if you look at the third column here, we have maximum zeros 1, 2 and 3 zeros. So I'll cover these 3 zeros by drawing a line. So I'll just rewrite this whole matrix here down, and then we are going to draw the lines. C, A, F and P. 0, 0, 3, 1, 1, 0, 0, 2, 0, 5, 0, 0, 1, 2, 0 and 1. So you can see we have here this row which is having 3 zeros. Okay, so I can draw a line here, or I can also draw a line to cover these 3 zeros here. Fine. So let us go row wise. So I'll cover this row first. Okay, then I'll inspect and check whether we have any other row or column with 3 zeros. No, we have 2 zeros here, 2 here, and if you look at this column, we'll have 2 here. So I'll draw the lines here, one more here, and only one is remaining. So either you can draw the horizontal or the vertical line. Let me draw it for the column here. Okay, now count the number of lines which are required to cover all the zeros. So 1, 2, 3, 4. Okay, number of lines to cover all the zeros equal to 4. Now there is a condition in the Hungarian method which says that if the number of lines to cover all the zeros is equal to the value of n. What was n? N, as you know, we have taken n equal to 4, which is nothing but your number of rows or columns. And because it is a balanced problem, the number of rows and columns are same. So if this is equal, okay, equal to n, which is 4 is equal to 4, we have arrived at the optimum solution. That means we need not go to the other steps which is required to find the optimum solution. We have come to the final conclusion that this is my optimum solution, and now I can go ahead and do the assignment. So in the step number 4, I'll do the assignments. So again, to do the assignments, I'll note down the matrix again, rewrite this: C, A, F and P, 0, 0, 3 and 1, 1, 0, 0 and 2, 0, 5, 0, 0, 1, 2, 0 and 1. Now to do this assignment, you have to find or search for a 0 which is single in a row or a column. So after inspecting, you can find this column here where we have only 1 0 in this column. So I'll do the assignment by putting a square around it. Okay. Once you put the square here in this column, the corresponding row, if you have any zeros in this row, you have to just cross it out. So I'll cross this. Okay. Again, do the inspection to find any single zeros. Here we have a single zero in this column. So my next assignment will be here, and as I said, you have to cross any other zeros in that particular row or column. So we don't have anything we have here in the row. I have crossed it. Similarly, searching, we have this column where we have only single zero. I'll do the assignment here, cancel this out, and the last one, the column third one, this is my final assignment. Okay. Now using this method, we have assigned each, you can say, worker with an activity. Okay, these are my workers. So worker number 1 gets the activity cutting. Worker number 2 gets the activity assembly. Worker number 3 is getting packaging. And the fourth worker is getting finishing. Okay. Now we'll go ahead and just calculate the total time taken to do this particular job. So I'll rewrite this whole thing, the whole assignment. So let me write the activity first. So activity, the worker to whom we are assigning this activity, and the time required. Okay. Let us write cutting, then assembly, then finishing, and finally packaging. The first worker is here 1, then we have 2, this was assigned to 4 and 3. What is the time required? If you remember, the time required for cutting was 14, and this we can easily get it from the original matrix. Here you can see 14. Okay. For assembly, which was 2, so 18. So let us write this out. 18, then we have 14 for F, and for P, packaging, we have 3. So I'll write this out here: 14, 18, 14 and 3. Let us add this up. You can see we'll get here 9, 1 carry 19, so 49. This is my total time taken in minutes to complete the whole activity or all the 4 activities. And remember, this is your minimum time. Fine. I hope you have understood. You can go through this video again and try to understand the problem. and the steps which we have taken to solve this assignment problem using the Hungarian method. As I told you, this was the simplest one. In the next video, we'll see a bit of a complex problem and how to solve a complex assignment problem. Thank you. Keep practicing.